Hello everyone, welcome to today's section. Today we'd like to discuss about the Compose performance. So first I'd like to thanks to my co-speakers, but due to some visa issues, they were not able to come here. But thanks to Zheng, Dingkui, and Zheng and our mighty infra team to provide valuable source to this presentation. So next, I will first introduce about myself. So my name is Qifan, and I'm from the TikTok social team. Our team is mainly responsible for the TikTok story creation flow. So in the past year, I have been working on the Compose migration and performance optimization. So today's content is strongly related to our frontline engineering experience. And today's agenda is quite simple. So first, I'd like to talk about the common Compose performance pitfall, and then we'd like to discuss about how to identify the Compose performance issues and how to solve them. So first, let's clarify the issue of Compose performance. Compose is definitely the future of Android UI, and the adoption of Compose has been exploded. In TikTok, there are more and more teams start to use Compose to build their UI, but here also comes to some challenge, like where declarative UI makes code cleaner, it might also introduce some runtime overhead, especially for the developers that are new to Compose world, so they will easily make some mistake. So this sounds maybe a little bit dramatic, but Compose definitely provides stronger ability for developers. But if we don't use it correctly, it can cause the app's performance degeneration. So during our daily life, we might run into some problems like why my Compose string shattered when scrolling, or why does recomposition happen even when the state didn't change, or why my APA grow maybe 3 megabytes after migrating to Compose. Those all kind of bad experience may all relate to the Compose performance issue. And generally speaking, Compose performance issue can be grouped to the 3 types according to the Compose UI phases. They are composition, measure, and layout phase, and the drawing phase. So first, we need to understand what did Compose do in those 3 phases. The first is Compose. This is the phase where Compose builds the UI tree by executing your composable function, and it will determine what needs to be displayed based on the current state, and it will record the UI elements into a data structure called slot table, and it will track which part depends on which state. So when a state changes, only the composable that consumes that state will be composed. It will allow framework to update the UI efficiently without rebuilding everything. This is definitely the most unique phase about Compose, and it's also the easiest phase that developers might make some mistake. And so we should always bear in mind that every composable with state can recompose, but not all should. And the second one is the layout and measure phase, where each composable is measured and positioned according to its parent constraint, and the system will work through the hierarchy and ask each component how large you want to be, and then assigning the space based on the layout rules. This step will define where and how large every element should appear. It will make sure the final layout fits together correctly on the screen. And finally, we have the drawing phases, where the Compose actually random pixels to the display using the Skia graphic engine, and its node draw method will be invoked and to draw its content, and also the modifiers like background, clips, or border will be applied. And this is where the visual appearance is finalized, everything calculated earlier in composition or layout measure phase is transformed to actual graphic shown on the screen. So understand those 3 phases will help us to attribute problems to the correct level, and hence come up to some solutions. So for the next section, let's talk about how to identify the performance issue. It's definitely the most important section because a problem well stated is a problem half solved. Once you locate maybe what's going on, it usually won't be too hard to solve them. So as a developer, we have two paths to identify the problem. It's very natural that the first one is offline path. It refers to the period before a developer's code emerges into the development branch. And just during this stage, we can locally detect recompositions in Compose and analyze performance issue using local profiling tools. And also we have the online phases, which means the developer code are already released, and we can monitor compose performance using online instrumental or event tracking and other monitor tools. So in a word, we can find possible issue offline and verify real issue online. So let's talk about the offline path first. Here we have a very important conception is recomposition. So finding the problem in this path, we focus mainly on the recomposition. If we don't write fancy layouts or drawing, which we usually don't need to, the entire of our Compose code is for the recomposition. However, it can be tricky to predetermine the exact recomposition behavior at coding time or even at runtime, because recomposition can happen very fast and it often doesn't induce shelter on your screen. So this is tools like Layout Inspector, systrace, and macro benchmark come into place. But before we using any tools to determine recompose counts, we need to know how many counts are necessary. So here are some factors that trigger recomposition. The first is, of course, changes, but we should beware that when a state value change, only composable that consuming that state should recompose. And also we have the parent recomposition. If a parent recompose and if the child node are taking some unstable value, the child will recompose as well. And also we have the list update, which means when you adding, removing, or adding any items in a list, ideally only the affected items should recompose, not the entire list. So always remember to use the stable key. And we also have the animation and gesture handling. So most well-implemented animations should not trigger recompositions every frame of this animation. Okay, so let's talk about the layout inspector. The recomposition count in layout inspector is a powerful tool to visualize and track recomposition in real time, and it's definitely the most accessible tool for us to grab the first impression of how recomposition happened on Happy Path. So here we have a screenshot about our story edit page, and if you can see, we use layout inspector to check the toolbar part, and you will able to see the hierarchy of the whole composable, and you will able to see the recomposition count, and even more you will have some information about the current state. But here focus on the performance. The most valuable tool will be the recomposition count. And once we found abnormal recomposition in layout inspector, we might need to identify why it recomposed against our design. So here is why we use breakpoints. Probably breakpoint is very common. We use it every day, basically every day in our development life. But it also works pretty well in Compose development. So if we adding a breakpoint to a composable function, it will first show you the composition root, and if we expand this recomposition root, you will be able to see the detail the composition child, and the recomposition state is determined by its parameters. And if we keep zooming this screenshot, you will find this recomposition is happened because of the text, the argument 1, 3, and 6 are changed. And also, here is also one trivia knowledge, if the Compose compiler insert code before our handwritten code. So even if we set a breakpoint in the first line of our composable function, it has already computed or skipped the related logic by that point. This means that the information you see in the debugger, it will be accurate. Okay, so sometimes we might want more than just the recomposition number, and after getting the recomposition number right, there is still plenty of optimization rules like rooms like across other phases like layout or like drawing phases. So like we can also use these traits for compose performance analyze, which is like arguably the most powerful and comprehensive way to inspect and analyze it. So here is also an example. So in production in TikTok, we use B-trace from our company to insert deep trace section to visualize every method, and also B-trace is an open source tool. So if you are interested in it, you can check it through the GitHub. And okay, let's back to it. So through trace analyze, we can find some like optimization insights, such as it will help us to identify which phase is the actual bottleneck. It is composition, measure and drawing, or like because like if you see here, like each method, like the width of each block is actually the duration. So like usually we try to find the most time consuming function and to try to see if we are able to find some way to optimize it. And also we are able to find nested recomposition or like layout fit. Because like as we discussed before, like when a parent recompose, like we usually don't want the unaffected child recomposed, and through the trace file you will be able to find the nested recompositions. Here is just an example, and also like you will find a lot of detailed information about each function in the trace file, like the running time and like the which thread called this function. And also, like we can understanding the cascading effects of the state changes. And also here, from this screenshot is actually also our edit page toolbar screenshot. And this is happened when a user try to expand this toolbar. As we discussed before for the list updating, so ideally when a user expand a list view, it's just like adding more items into this toolbar. So ideally, the already existing item shouldn't recompose, but from this screenshot, you will be able to find like from the red blocks, there are two already existed items, but they are still recomposing, which means our toolbar recomposable functions definitely has some problems. Okay, so besides all the tools we mentioned, we can also use Markov benchmark to measure the compose performance. But first, why we need Markov benchmark? Sometimes debugging and running trace on heavy paths is just not enough. And Markov benchmark is a great way to verify the optimization gains. And sometimes maybe some small like compose UI refactors may be not worth it to add any like online event tracking or like experiment. So here is like the offline, like the unit test coming into use. And also for the Markov benchmark, it like cold starts the app each time. And unlike the micro benchmark, it only cold starts the app once and will run the test after that. Okay, we will also give a very simple example here. So like it's pretty easy to use Markov benchmark. You can use Android Studio's benchmark templates, and also since the module is independent from our app, it's basically like the unit test. You need to add the content description to your composable function UI element to make the Markov benchmark able to notice your like function. And also like the Markov benchmark provides some like common metrics. It's usually some function running times. Here is one thing we need to aware of is that like all metrics rely on analyzing trace collected each time, which means if you want more customized analyze sessions, you have a customized like a UI component, you want to use Markov benchmark, you need to manually add trace sections in the code. Okay, so here is a screenshot about the Markov benchmark. So you will be able to see all the like minimum, median, and maximum metrics from this screenshot. And also after we use the Markov benchmark, we have two interesting points we want to share. One is that the device thermal loading has a significant impact, which means like the first and the last test in the Markov benchmark will have some substantial running time difference. And also like the package version is quite different. quite important. So please remember to use the same package version, and we recommend you use the update installation to preserve all the like experimental mental variable. Okay, so here is a more visualized graph to show you how the thermal throttling effects works. Like you will be able to see maybe the first 15 runs for the Marco benchmark, they are very stable and they generally are faster compared to the last one. But still, Marco benchmark is pretty reliable, so you can still use it to get the reliable baseline for your code. And once you get the baseline, and if you make some changes for your composable code and you rerun the test and you found like maybe the recomposition count has like significantly increased, you probably want to check what's wrong about your code. Okay, so after we talk about all those tools, but still, if developers merge the code without validating the performance of their compose functions, it may lead to the overall app's performance degeneration. So therefore, our infra team, usually it's infra team, aims to monitor the recomposition counts across the whole app and it's online. So here, I'd like to share about one strategy we are using is that use hook to hook into the composition code itself to help us to report the online recomposition count. So first, let's look at the hook mechanism. So hook is allowed developers to intercept and modify the behavior of a method without just directly changing their like original source code, and you can inject your customized logic before, after, or even in place of the original implementation. So here, and after that, we need an identification for each composable functions. So we have a key and an anchor ID. Anchor is an internal reference that used to locate a position within the composition tree for efficient recomposition. And also, we definitely need a data collection to track the number of recompositions and the number of times recomposition was skipped. So after we having that, we can start our hook. So we are able to insert hook as a creative point to the method called start restart group. This will call when a composable function starts execution. We capture the key and anchor ID, then increment the recomposition count. Similarly, we can also hook to the skip to group and function. This will run for like when a composable decided to skip recomposition for a composable. So this will allowing us to verify like how efficiency about our optimization. So with all of that, like we are able to monitor the compose performance online. Okay, so I know it's a little bit overwhelming for me to discuss a lot about it, so let's just have a brief summary. So like for the offline path, the developers can use layout inspector to use the breakpoint, trace analyze, or Marco benchmark. And for online, if you want to monitor the like real time, real user, real data's compose performance, you can also use hook to inject into the compose functions. Okay, so after we figure out how to locate the compose performance issue, let's talk about some common solutions here. Also, we divided our solution to two types. So the first type is like the product team solution. The product team refers to the groups that responsible for business feature or requirement. So they typically focus on optimizing performance issues within their specific domain, and all of their solutions might focus on how to solve an individual problem and could have more unique way to solve them. And also we have the infra team solution, and they will take a broader app-wide perspective and aiming to improve the overall system performance and also provide a more general solution to benefit all the product teams. So let's take a look at the product team side first. So we will have some strategy to reduce the composition because it is the most of the important parts that we can optimize. So the first one is use the non-state reference or object. We will have an example here, so this is a bad example, so don't do it. Like if you sit in this composable function, so like if you check the modifier, it will take the position state dot value to during the composition phase. So if this composable function is called during an animation, like let's say it has like 60 FPS, so it will trigger a full recomposition of the box. As a result, the composition layer become overloaded, and it will definitely cause the UI jank. So what we encourage us to do is like just use the graphic layer blocks to run, because it like run during the layout and draw phases. So even if the position state dot value change frequently, like such as on every animation frame, it will only trigger the redraw, not the recomposition. So this will significantly reduce the recomposition frequency and will improve overall performance. Okay, so second, we also have one strategy that is to split and extract states doing using the derived state of method. And we will also give a bad example here. So every time any field of the fixed state dot value changes, like the whole screen will changes, like every UI element, because like even if maybe just one postcard information changes, like all postcards get recomposed as well. So we definitely don't want that. So how we do it, optimize it is like you can use derived state of. It ensures that recomposition happen only when the derived value change. So if only post change, like the user header won't recompose. So keep state as close as possible to where it used is pretty important. And using the derived state of will create the precise state scoping to leading to fewer recomposition and smoother UI performance. Okay, so of course we still have one more, is like award the recreating modifiers. Always use the remember method to catch the modifiers. And from the bad example here, like if you can see like every time this composable recomposed, it will create a new modifier chain. So which means it's like the compose compare modifier instance to determine if this node can be reused. So if you create a new instance, it means like you have a different identity and it will trigger the layout invalidation. So this will increase the measurement and layout cost unnecessarily. Okay. So here we can also use remember to catch the modifier chain so it won't recreate each time. And also we can use block variant. If you see the clickable here, like in the bad example here, we use lambda to add the on-click method, but in the good example, we use a block variant. We just pass it as a parameter. It will also avoid to create a new lambda on each component, like on each recomposition. We will talk about this later, about like why the side effect about create like too many lambdas. So basically this keeps the modifier identity stable and it will preventing unnecessary layout or draw updates. Okay, so I know like the real world issue might be far more complex than those strategies share about, and there are definitely a lot of strategies, but we just like cannot cover them all. And so we'd like to share about a real world example about how we solve a compose performance issue in TikTok story album. So this is a screenshot about our story album. And so first, at the beginning, we got an event tracking that shows that currently for our social album is the story album. For the frame skipping during the social album scrolling, it still have a certain gap compared to other album in our app, like the second one and the third one. So after we got that information, so we start to investigate the trace. The trace inspector revealed that the layout phase consumes a significant amount of time. Like if you are able to see this lazy grid measured method, I'm not sure if you are able to see it, but it's like basically take like 600 milliseconds, which is like insane. So and it's also with like hundreds of items being measured simultaneously. So it definitely, of course, it will result in a severe frame skipping. So let's go further to check what happened to that method. So here is the source code about the measured lazy grid method. So because in the story album, like we use the score state.score by method, and the likely appearance may be related to the because if you users like score the album really fast, and from the relevant source code, if you can see, because if you look at the while loop, like it has the first line here, like the value previous. It's like we'll check the line by line. So which means like if user are just like quickly score the story album, it still has to check the every line. So it can be like, so the displacement on one frame will be larger, and the number of items that need to be participated in this layout will be very large, and will cost the unmeasured time, like you see in the trace file, will be very long, and also the long frame will further lead to an increase of the displacement of the next frame and result a frame drop. So like how we resolve this problem, but the solution is actually quite simple. We just change the score by function to to score to item function. So here is two demos about like if you are using the score by method and the score to method. So if you score the this list really fast, you see the score by method will be like seems really laggy, and the score to item is so smooth that it's like appear that it's like basically didn't move, but it's actually like we are quick skipping score it, but still like you can see the difference is like very clear. Okay, so after that, let's jump to the infra side. We will have some like more general solution here. So the first one is to use the baseline profile. Like Compose is distributed as a library instead of as part of the Android platform. This approach lets the Compose team update Compose frequently and support a wide range of like Android version, which is good. However, distributing the Compose as a library will impose a cost. Because like Android platform code is already compiled and is installed on your device, like on user's device. Libraries, however, need to be loaded when the app launches and like interpreted just in time when needed. This can slow the app or like on startup, or like when you need to use this library feature for the first time. So by adding Compose code to baseline profile, we can make them bypass the just-in-time compiler and improve code execution speed by about like 30% from the first launch. And by shipping a baseline profile in an app or library, you enable Android runtime to optimize, like including code paths through the ahead-of-time compilation, providing the performance enhancement for every new app installation and every app update. So here in TikTok, we are not only add the default Compose baseline profile, we are also include our Compose theme, which is like, because in every app design, like we will have a standard for or UI theme, like for which color we should use. You will see this red is definitely a thing in TikTok, and like other things we will also if we are using Compose development UI, we also need the Compose UI module, and we also add that one in the baseline profile. Okay, so the second one is the lambda merge. So as we discussed before, like so if you are create a lot of lambda merge, you will have some like performance degeneration. So in Compose, a larger number of lambda methods are generated, which can lead to increased package size and performance degeneration. as I discussed before, because like the class looks up can take some time. So here at TikTok, we address this by using Redux to merge those lambda method. So if you see here, like for the this is the Redux is the like bytecode tools, but here is it will generate just a merged class. It like extends the lambda class, and basically what it do is like you will see for the two individual lambda method, it will treat it as one lambda method with different tag. So it will use tag to track the different lambda method. Maybe an example is like maybe clear here. So for example, if we have one button and we will have two click method logic, the one is like click logic A and like other is B. So without lambda merge, we will each lambda will be translated into an anonymous class by compiler. And after we have the lambda merge, only a single class is created and multiple lambda instances share this class. So in some cases, even the same instance like is reused via cache. So that's what like lambda class did. Okay. So next is like Q&A session. So I think we still got some time, but like also you are more than welcome to come to that to discuss with me. Okay. Okay. So okay. Thanks everyone to join today's sharing. Thank you.